These warm-ups are going to be beneficial for reviewing old material because once we get to December and it's time for our midterm, you might not remember these if we don't do them from, the last test until then. So that's why we're going to be reviewing old material on the warm-ups, okay? All right. While I try to simplify this radical expression, I'm going to cover up the answer choices to give myself some scratch paper to do it. Okay, they want us to add them and subtract. To be able to do that, what's the rule? Correct. They have to match, but they don't because this one has a 45, this one is 20, and this one's 5. So you're going to simplify the ones that you can. Can you simplify the square root of 45? Yes. What are the factors? What are the factors of 9? 3 and 3. People need to pay attention. 5 is prime, so it just comes down. Now that you have all prime factors, what do? Circle, kill, and kick out. And then that 5 gets to go back in the house. Shh. We are now done simplifying the square root of 45. Now can we simplify the square root of 20? Yes. What are its factors? Which is a 5 and a 2 and a 2. So we have a pair of 2s. One gets killed, one gets kicked out, 5 goes back inside. So now we've simplified that. Don't forget to bring down the plus sign between them. Can we simplify this? No, because 5 is prime. So you just bring it down. Don't forget the minus. And I also recommend that you go ahead. If this is a 3 on the outside and that's a 2 on the outside, what's on the outside here? And I would write it. That way you don't forget about it when you're combining them. Okay, now, when you're combining them, it's like combining like terms. The reason you're able to combine them is because they all are square root of 5. So that's part of the answer. You don't actually do anything with those. What you combine is the outside numbers. 3 plus 2 is, and 5 minus 1 is 4. Okay, now let's check the answers and see which one was right. Okay, it was A. Okay? All right, so remember we're going to have one of these a day. For right now, just do it on scratch paper. Eventually, we may move to doing it in the device or on paper. We'll see. The little clicker things, Okay. Now, before I move on, does anybody have any questions from yesterday's work? Page 4, 5, or 6? I need y'all to be quiet because I'm trying to teach. Number 12 on this page? Okay. I had to move around some people because of behavior issues or talking issues. All right, number 12. Number 12. 8n plus 15. Can you add the 15 to the 8n? No. So you just bring it down. There's nothing we can do to simplify that side of the equation. Is there anything we can do to simplify this side of the equation? Yes. There's a negative on the outside, and that's a negative 1 that you can distribute. So what's negative 1 times 3? And what's negative 1 times negative 5n? Positive 5n, because a negative times a negative is a positive. Okay, now what can I do? There's 4 different options here. So what do you want to do? Add the what? Okay, but add them? They're both positive. Subtract. Which one do you want to subtract? Okay, so if we subtract 5n, on this side it'll cancel, leaving just the negative 3. And then if you subtract it over here from the 8n, you now have how many? 3n, and then bring down the plus 15. Okay, now at this point, there's only one thing you can do, and what's that? Subtract the 15. And so you get 3n equals negative 18. And then what do? Divide by 3. And so n equals negative 6. Okay, you can even check these kind on your calculator. Let me show you how. Okay, the first thing I'm going to do is I'm going to type in this side, 8n plus 15. But anytime you are plugging in a number for the n, what do you put around that number? Parentheses. So I'm going to open a parenthesis, plug in the -6 where the n was, and close the parenthesis. Then add 15, and I get -33. Shh, there's too much talking. Okay, now I'm going to do it to this side. You type in exactly what you see, so negative, then parenthesis, then 3, parenthesis, 5, but now I have an n. So in the place of n, I put a -6, but I put parentheses around it. And then also that parenthesis that was already there, and I get -33. Is that a true statement? Is -33 equal to -33? Yes, which confirms that I am right. Okay, I got to make some moves. Okay, any other questions off of pages 4, 5, or 6? No? Okay, let's move on to today's material, page 7. All right, I am going to be doing about 5 of these with you, but I'm going to be skipping around because there are several types of word problems on these pages, and I'm going to go over one of each type. That way you'll know how to do the rest. Okay, so let's start with number 1. Number 1, I don't know, Wong, I guess, had $23 to spend on 6 notebooks. After buying them, she had $11. How much did each notebook cost? Okay, the first thing we're going to do is set up an equation. How much money did she have to start with? Okay, so that's what we're going to start our equation with. What's she going to do with that money? Spend it, which would be what operation? Right, she's taking away from that $23 by buying what? Do we know the price of a notebook? No, so for right now we'll put in for the price of a notebook, but we know she's buying 6 of them. And then after she makes that purchase, she has $11 left. So does everybody understand how I set up the equation? Now, if you wanted to, you could have also written it -6n plus 23, and that's the same thing, but to me this makes more sense how we wrote it. What do you do first? Subtract 23 on both sides. And so you have -6n equals what? What's 11 minus 23? -12 though. Okay, because you're subtracting a bigger number than you actually have, so it's going to go into the negatives. Then what do we do? Divide by -6 on both sides. And so, too much talking, n equals what? +2, because a negative divided by a negative is a positive. Now, that's to what? $2 per notebook. Okay, now let's skip down to number 4. I'll give you time to copy. Okay, can we move on? Okay, number 4. Shauna rented a bike from Arjun's Bikes. It costs $14 plus $3 per hour. If Shauna paid $32, then she rented the bike for how many hours? Okay, well, what does she definitely have to pay no matter how long she keeps the bike? Right, that's like a rental fee. Plus $3 per hour. 3x, or I'm going to put h, that way at the bottom when it says h equals, I'll remember that that number is hours. And then that should equal up to $32. So the $14 rental fee plus the $3 she's going to pay per hour that she keeps it will total up to $32. All right, what do I do first? Subtract 14 And that will become 3h equals what? 18. Now to solve for h, what do I do? Divide by the 3. So h equals 6. And that's 6 what? Why did I make it an h? Hours. That's why I made it an h instead of an x, because I knew h would stand for hours. Okay, now let's move to question number 5. Everybody good? All right, number 5. The sum of 3 consecutive odd numbers is 69. What is the smallest of these numbers? We've done this before. What does consecutive mean? Like, you're right, no skipping. Correct, like 1, 2, 3, or 4, 5, 6. But this time, it's consecutive odd numbers. So what do they mean by that? 5. Right, like numbers like 1, 3, and 5, or 5, 7, 9. Consecutive odd numbers without skipping any odd numbers in between. And they should add up to 69. But do those 3 add up to 69? No, but they can help us create the equation that will figure it out. If we assign 1 the variable x, so every time you see an x, you think 1, what would we need to call 3? X plus 2, because that's like a 1, so 1 plus 2 is 3. And what would we call 5? Right, because that's 1 plus 4 is 5. When we add them up, because it says the sum equals 69, now what can we do? Combine like terms. When you combine your like terms, what do you get? Right, 3x plus 6 equals 69. Then what do we do? Right, so 3x now equals 63. Then we divide by 3 and x equals 21. Okay, now, they want the smallest of the numbers. Is that the smallest? Yes, because think about it, that's just the regular x, which would have been your smallest number, because your next number is going to be 2 more than that, which would be, and then your next number would be 4 more than that, which would be 25. Do those numbers really add up to make 69? Yes, but remember, only 21 is your answer, because they only wanted the smallest number. Okay, number 6. Pay attention, I'm doing 2 more problems, and then you're going to work these on your own. For a field trip, 25 students rode in cars, and the rest filled 8 buses. How many students were in each bus if 321 students were on the trip? Okay, so we know the total number of students on the trip were 321. And we know that 25 of those kids were in cars. We don't care how many cars. We just know 25 kids out of the total were sitting in cars. Plus what? 8 buses. So 8 buses, but do we know how many kids are on each bus? Well, that's what we're trying to figure out. Okay? So what do I do first? Right? Take the 25 car riders out of the total so you can figure out how many bus riders you have and how many bus riders are left once you take the car riders out. And now you can take those 296 kids that you know you got to fit on a bus and divide it by 8. 37 students per bus. So now do you kind of see how something like this could be used in real life when you're going on a field trip? They kind of got to know how many buses to ask for. Okay, so even though it seems complicated, it's really not. You just do a little bit of algebra in your head and you figure out how many buses you need. Okay? Because if you don't, what's going to happen? You're either going to not have enough buses and you're going to have kids standing out there on the sidewalk, or you're going to have too many and you're going to have paid for an extra bus, and those buses are not cheap to rent, believe it or not. Okay? Yeah, the school buses are not cheap. Okay, now I want you to skip page 8 and go to page 9. And we're going to do question 14 together. This is the last one I'm doing with you. Okay, Bill spent $39 on a magazine and some candy bars. If the magazine costs $4 and each candy bar costs $5, then how many candy bars did he buy? Okay, well, what does our equation total up to? Right, because that's the amount of money he spent. Now, he spent it on two different things. What and what? Candy bars. So I'll just use C for candy bars. And what do we know about candy bars? $5 each. But we don't know how many. We'd have to plug that in once we find it out. And then on top of that, he bought what else? A $4 magazine. Why do we not need to put like 4M? Right. He only bought one. Okay, so that's a one-time, that's a constant. He's only going to pay $4 once for one magazine. But he's buying several candy bars at $5 each. So now to figure out how many candy bars he's buying, what do I do? Subtract 4. Right. And so that means he bought 7 candy bars. Okay, you need to be working on the remaining problems that we did not do on pages 7, 8, and 9. We still have 18 minutes in this class, so that's a lot of time to get most of this done if you don't want homework.